This slide shows our exact focus for today: developing strong research questions for your PhD. Welcome to this session, guided by the methodology of Dr. Ala Jabbar Al-Maliki from the School of Computing at University Utara, Malaysia. This flowchart illustrates exactly where we are in the research lifecycle. You have reviewed the literature, identified the research gap, and written your problem statement. Now you face a critical decision. What exactly are you going to investigate? The highlighted box shows where your research questions come in. Think of your PhD as a logical sequence. This research chain shows how a general problem converts into a measurable inquiry. Your research questions sit at the center. They dictate what data you collect, determine your methodology, drive your analysis, and shape your precise contributions. A common error at this stage is to select a popular technology or methodology first, and then force a question to fit it. You cannot decide that your PhD requires a generative AI or blockchain framework before you have justified why that specific tool is required. The process works strictly in one direction. The solution follows the problem. Every research question must have a clear, documented reason for existing, and that reason must be clearly visible in your problem statement. This split-screen layout displays a complex research problem regarding cybersecurity. It states that despite high detection accuracy on benchmark datasets, the effectiveness of AI intrusion detection in real-world networks remains uncertain due to evolving cyber attacks. Before writing a single question, we break this text into manageable components. The first extracted component is the high performance of existing models on standard benchmarks. The second is the uncertainty of their performance under real-world network conditions. Next, we extract the third component, the distinct challenge created by unseen and evolving cyber attacks. Finally, the fourth component identifies a potential need for an approach that improves model generalization. Breaking down the problem statement directly prevents you from asking one enormous, unanswerable question like, how can we solve AI cybersecurity problems? We now have a foundation of specific variables that can be individually investigated. This tiered list maps our extracted components directly into focused research questions. We start by establishing a baseline. Research question 1 asks, what limitations affect the generalizability-based approaches? We must understand current weaknesses before proposing improvements. Research question 2 moves from understanding the limitations to measuring their actual impact. We ask how the performance of existing models changes when evaluated against real-world traffic. Research question 3 shifts toward addressing the problem. We ask, what specific approach, perhaps a new hybrid method or feature selection technique, can actually improve detection capabilities? Research question 4 evaluates our proposed solution. We measure exactly to what extent our new approach improves performance compared to existing methods. Notice the progression here: understand, evaluate, develop, validate. PhD examiners actively look for this structure because it creates a logical, highly defensible research journey. This chart contrasts common phrasing errors with strong alternatives. In the first row, asking how can cybersecurity be improved is too broad. The specific, checkmarked alternative clearly identifies the technology, the exact issue, and the target environment. Avoid questions that can be answered with a simple yes or no. The red text stops deep investigation. The green text uses to what extent, which forces you to measure the improvement, compare results, and analyze conditions. Take a moment to read the question on screen. Can you spot the fundamental flaw in how this is written? The error is confirmation bias. The wording explicitly assumes the new model will significantly improve accuracy before any experiment has actually taken place. We fix this by removing the assumption. To what extent does the proposed model affect performance compared with existing approaches? Now, hard evidence determines the answer. The precise phrasing you choose will depend on whether your study is descriptive, comparative, explanatory, or design-focused. Different question types require entirely different methodologies. A doctoral research question exists to test a claim through empirical evidence, not to assume a claim is already true. This research alignment table is a strict tool used to verify your thesis's structural integrity. We map a single problem component to a specific research question. That question maps directly to an objective, pointing to a specific method, which ultimately yields quantitative evidence like accuracy and F1 scores. This checklist outlines the requirements for a strong question. It must be clear, focused, researchable, connected to your problem, and significant. Most importantly, it must be feasible to complete within your PhD timeline and require genuine investigation rather than pointing to an obvious answer. You work from the research gap, to the problem statement, to the research questions. The final step in this planning phase will be translating these refined questions into measurable research objectives. If you formulate a research question but lack a valid method to answer it, or if you plan an experiment that addresses none of your questions, your research design has a structural break. Rigorous alignment between your problem, your questions, and your methods is the true backbone of a successful PhD.